This project was actually inspired like the beginning of the year when the prototyping units and others were coming with discussions that there is an inherent problem which we call the scaling problem, and this idea here is one way to tackle that for certain use cases. So what is the scaling problem in general is that there is a limit which is inevitable about the amount of computation that you can put into a single Cartesi machine, right? I mean, that's a fact. So if you put more than that, then it will start to lag behind the inputs that are coming. So what that means for dApp is that if you have a situation where the computation increases with the number of users, which is pretty common, then obviously you reach a limit at some point. So an example of that, for a chess game, for instance, if you have the chess front end there where the people are playing and they join a game, and you have a single Cartesi machine there, a single dApp, and everybody is joining the game, sending moves, and then getting the result. What happens if you have like 1 million people playing? Then some people will start, everything will start to lag behind, and you won't see the results of your games very soon, right? If you have these millions of people, so people will just drop the game at some point, which is not what we want. So, and this is, of course, if you think about other games, and we have some examples like Dazzle and others, if the computation is more intensive, then maybe you can even fit 10 games in a Cartesi machine, and it's already a problem. So we're talking about millions of people here for this example, but it's you don't need millions of people necessarily to hit this issue. So the solution that we thought about was sharding, which is a pretty basic idea. So instead of you have different Cartesi machines to handle different either single match or groups of matches, but for simplicity here we're talking about single match. So you would split the computation to several machines, and this way you could scale horizontally, right? And we call each of these machines a shard of the dApp. So what's the issue here? You need to coordinate these things and you need to make it sustainable. So the idea is that for certain games like chess, you can put the game logic in the front end, and people can play each other normally, right? This is the happy path, let's say. And what the idea is that you have a main dApp that just records what are the results of each game, the general rankings, leaderboard, etc. And you could have these extra verifier shards, which are only created when there is a disagreement. So if the people are fighting each other and saying who won, you then run these shards to run the logic of the game in the Cartesi machine and verify the correct result of the game. And the cool thing about this idea is that if you reach that situation, then the costs can be made to be covered by the misbehaving party. So it's sustainable. So you don't. So the first thing that you imagine when you say, okay, I'm gonna scale my game, I'm gonna put 100,000 Cartesi machines to play it, then you obviously who's gonna pay for that, right? So this idea is that you only have one, the main dApp, and if anybody is fooling around, then they will have to pay for it. So to illustrate, this is the happy path. So people from the front end here, they start a game in the main dApp. Then there is this special contract which is called the dApp sharding contract. With the game started, you have an ID of the game, an identifier, and you can get an address for that game. And then you send moves on the Cartesi Rollups input box for that address, even if that address is nothing. There is nothing there. It's an address of a future shard to compute the verification of the game, but that doesn't exist yet. And if people agree in the end, you just claim the results. So the moves are stored on chain, but never used in this case. They are only going to be used if there is a problem, right? So if there is a problem, which is a dispute case, what happens is that the user who detects a problem and is unhappy with the end, with what's going on, he can call this dApp sharding contract to create the shard to verify. And that would deploy a new verifier dApp using the same deterministic address that you had before. So you ask the dApp sharding contract, what is the address that I should use for this game? And then if you need, you create the shard, and it creates a shard exactly in that address. So that what happens is that when you start up the node for the verifier, it will just suck in the moves, all the data that's collected into the input box, will compute all of that, and then it will issue a bit of voucher to inform the result to the main dApp. So this way, there are some details here. So the main dApp will receive information of the creation of this verification and who created it, and will be able to slash people if the misbehaving party and get that money back to who had to do all this work to verify. So the idea is that people will deposit just enough money that is enough to run a Cartesi machine to do one verification, so that it will be made sustainable. So this is the idea. What we actually did is that we have the dApp sharding contract ready. It's deployed to Sepolia. There's a deterministic address there, so it should be the same address for every network. We have these two methods: calculate shard address, giving some parameters, and create shard with the same parameters, and it will create a shard with the same address. We have an npm module, so you can use that with ethers typing, etc. This is the GitHub for it, so it's there. We have a nice front end that you can play, which currently plays both sides. It gets the game address from the dApp sharding, sends a move to the input box, and then you have a button to trigger the verification, create the shard. And when that happens, you can run the verifier dApp, and it actually processes the game and emits the voucher with the game results. The main dApp is there just to start the game and acknowledge the result. So we have everything working. Do we have time for a demo? I'm not sure, right? But for the voucher thing, we still have some issues with Sunodo, which I kind of got around it, but we still have some issues to get the voucher really being executed. I had one final slide here with features that we would like to have, but I guess that could be extra features that we'd like to have, which is Sunodo could instantiate nodes automatically when a Cartesi dApp factory is called to create the dApp. So that would be the idea, right? That these nodes, verifier nodes, they start up on their own. I think Sunodo is already planning to do that in the near future. We would like to have a way to decommission a node when it's done. So I don't know if you noticed, but this is kind of like a Cartesi compute in the rollups framework, right? So in this case, specifically, the shard ends at some point, right? So we just use it for a while and then we shut it down. It would be kind of like a compute. So we have this idea here. That's it, I guess. I mean, I could try to run this thing, but I think I'm out of time, right? Already. So I don't know.
I'm always in favor.
Should I stop?
Can you run it super quick so we can see it?
Yeah.
Or does it take a while?
No.
Nice. That's super nice, by the way.
Is it ready?
Nice. Yeah, let's get some. The people are in favor of running.
Okay. So this is our dApp. By the way, this is the sharding thing. If you want to fool around, and then we connect.
Oh, it's
Thanks
on
prototype. This is on Sepolia, yeah. Thanks prototyping unit. I copied some code from you to get this wallet working. And then we start a game. So we send this input to the main dApp. It's slower when we are streaming. And then we can play the game, right? Each time we play, we submit. So like Danilo said, there are ways to make this better, right? But this is what we have. And then anyway, we could do all these things, and then, yeah, checkmate already. Don't know if you noticed, but this is the quickest possible chess game. I still need to confirm all the transactions. I think I'm done. And you see here, I have the shard that was created. And I can ask the game to be verified. When I do this, I will call the create shard method. So at this point, I can run a validator node for the verifier, which is this guy here. And I have a small script here, which is to run the validator, but I need to run it for this shard. By the way, if I tried to do this before, it would fail because there was no Cartesi dApp there. So I need to, it can only really run the validator after that thing is there. And this will run, it takes like 10 seconds to start up, and then it will start processing the moves and emit the voucher. Hopefully this doesn't take too long. Yeah, it's slower when I'm presenting, definitely. It's right now it's trying to read the inputs, so it starts from, it doesn't start from Genesis actually. I set some specific inputs so it will be faster, but oh, there it comes. Yes, receive the move, received another move, received the move, and then he knows it's in checkmate, winner is black, and then he receives the information to, okay, it's over, please, and it emits the voucher here at some point. Did it already do it? Yeah, creating voucher for B here. So we create the voucher is there. I think we can actually check the voucher there in GraphQL as well. So, wow, this takes a long time when I'm presenting. Press it. Yeah, there it is. So that's the voucher, and we would be able to execute it if that was working. It's not really. So we can also see it here. So that's it. Thanks a lot.
Awesome, super cool. When are we gonna have a chess tournament for Cartesi?
Yeah, we have to finish the game first. So if we are sponsors to do that, we'll do that fast. And I think the one idea also is to put other games in this setup.